All right, all right. Welcome on in for our next session, team. Do we have any New Yorkers in the house? New Yorkers are always so proud. I love it. Anyone from the UK? All right. Okay, so y'all have something in common with our next speakers who are going to dig a little deeper into React. I'm going to welcome to the stage the amazingly wise and talented Brian and Mike.
Thank you. Hi, everyone. I'm Brian Rosenfeld from Instagram, and I'm excited to be here with Mike Armstrong from Oculus. Today, we're going to talk about how we use React Native and React VR respectively, along with some insights and takeaways from our experiences. Before we get started, I'd like to get a sense of who we have with us in the audience today. By a show of hands, how many people do web development? Awesome. And mobile? Great. How about VR? Mike, raise your hand. Okay, so we have a nice mix here today. So an Instagram engineer and an Oculus engineer walk on stage together to give a talk. This may sound like a really strange conversation to be having, or even the setup for some sort of joke. On one hand, we have Instagram, a mobile app running on many of the phones in your pocket, and on the other, we have Oculus, a bleeding-edge VR company. We even have web developers in the audience. So what gives? Despite being two very different products running on very different hardware, we independently started using the same framework, React, and for many of the same reasons. And no, I'm not just talking about for our websites. At Instagram, we use React Native to ship cross-platform Android and iOS features. And at Oculus, they use React VR to build immersive virtual reality experiences. Each of these is a very different use case than we saw with Ads Manager in 2016 at F8, which featured cross-platform Android and iOS apps built from scratch with React Native and running shared JavaScript code. And they're all built upon the same library, React. So where we normally require vastly different skill sets for mobile and VR development, Mike and I, despite our different backgrounds, can use and talk about the same technology. So let's get started. Here's what we'll cover today. First, Mike's going to give a brief intro to React, React Native, and React VR. Next, I'll talk about integrating React Native into our apps at Instagram. Then, Mike will introduce you to React VR and how it's used at Oculus. And I'll conclude by tying this all together, sharing some broader insights into our use cases and React. And with that, let me turn it over to Mike.
Cheers. Thanks for the amazing introduction, Brian. Hi, I'm Mike Armstrong. I'm a software engineer and work on React VR in Oculus. Now, you may have heard that we've renamed the public open source version of React VR to React 360 to better highlight its uses. It was a talk we presented at 12 o'clock by Andrew Moe. But internally, we also have our own version of React VR, and because we're actively using it for building VR, and it's the internal version that we'll be talking about today. So let's start with an introduction to React. Oh, I'm pressing the wrong buttons. Sorry about that. So before we embark on our journey into the uses of React in Oculus and Instagram, let's make sure we're all on the same page. Let's be honest, there's going to be a lot of terms flying around. But I think we'll start with something simple, like who in this room is aware of React? Great. So we got a good proportion. I'm not surprised given that we just had a panel before that. But for the benefit of those who did not put their hands up, React is a Facebook open source JavaScript framework, and it really, truly takes the pain out of creating UIs. But how, you ask? Well, it has two really important properties. Now, first, it's declarative, and that frees you, the developer, from having to think about how you achieve a UI goal, and instead just express what it should look like. This is really subtle, but very powerful stuff, and Brian will deep dive into this later. But there is also more. React is built on the concept of components. Now, we use this term a few times, so let me explain a little bit more. Components let you split the UI into independent and reusable pieces. And the components are actually designed to help you think about things in isolation. And as we all know, sort of when we and appreciate that fixing problems in isolation is just so much simpler. So now we have a basic understanding of why React is such a strong foundation. We can move on and we can start talking about these other parts. And this brings us to React Native and React VR. So imagine taking that lovely stuff that you've used on the web and being able to take that and to drive native UI and native code. Well, this is what React Native does. And React Native is another Facebook open source project, which takes that declarative and those components of React, those super skills, and applies them into driving native UIs and interactions on mobile. This is the learn once, write anywhere, where we can see applications on iOS and Android sharing over 80%, I think it was even higher than that now, of the same code. And this allows small teams to reach vast audiences with their applications. However, sometimes an app needs access to platform APIs, and React Native doesn't have that corresponding module yet. Well, React Native was actually also designed to support the extensions to the system, and these are often referred to as native modules. Both Instagram and Oculus have made heavy use of these. They're often overlooked, but they're super powerful. So this gives us a summary of React Native. Where does React VR fit in? React VR is built on top of React Native, and through new inputs and very different rendering, it allows teams familiar with React and React Native to create applications for VR. I'm going to go into much greater detail on the tech stack later on in the presentation, but in the meantime, I'm now going to hand back to Brian to discuss their uses in Instagram.
Thanks, Mike. So now let's look at how we integrated React Native at Instagram. To start, why use React Native? To set some context, let's talk about developer velocity. Developer velocity is a defining value of Instagram's mobile engineering. At Instagram, we work to scale our development experience with both app and team size. We strive to provide engineers with the tools, building blocks, and frameworks that let them feel the most productive and satisfied working on our apps and in our code base. And as an example, we actively track how long it takes to compile our Android and iOS apps. In early 2016, we started exploring using React Native as a way to allow product teams to ship features faster. Let's see how. Start iteration speed. I got my first exposure to React Native as a new hire ramping up on Android tasks. As an Android engineer, I was used to having to recompile, install, and cold start the app every time I made a change. This was bad for iteration, but a great chance to catch up on the score of the Yankee game or the news. At the time, there were already 2 engineers working on React Native at Instagram, and I picked up their task for matching the open source React Native behavior where double pressing R on your keyboard to reload the JavaScript on an Android emulator. With React Native's live and hot reloading, I could replace the entire compile, install, cold start cycle with a near instant change that never left my feature. I was sold. Next, React Native offers big portability wins. The same JavaScript code builds iOS and Android features that are indistinguishable from ones written using Objective-C or Java. Here, we have a simple push notification settings page written in React Native and shared between Android and iOS. Another portability benefit for Instagram was that we could share React Native code with an app like Facebook or Ads Manager despite having different native stacks. React's declarative layout offers an easier way to write complex and stateful UI code, scaling your work in the number of states, not transitions. And we heard this come up in the panel before the talk. Let's take as an example a notification icon. Normally, it's just a bell. If we have unread notifications, we'll show a badge with a count. And if you have over 99, we'll set it on fire so you know to really check it out. Say we have no notifications and suddenly receive 100. We'll now need to transition states. We need to add a badge. We need to set it on fire, and we need to set the badge's count to 99 plus. Let's think back to our starting state, the bell with no notifications. From here, we can either go to the bell with a badge or the bell on fire. In terms of n, the number of states, we need to handle n minus 1 possible transitions. This doesn't sound too bad, but when we factor in that for each of the n states, we can move to all the others, we find we have n times n minus 1 possible transitions. And what this means is that our work increases quadratically as we add more states and build more complex UIs. So now, if our designer comes to us and wants to add a fourth possibility, we need to handle 12 transitions instead of 6. In code, that looks something like this. As an example, you'll see we have a check at the top that if the count is greater than 99 and we didn't have fire, we now need to add it. If the count is now less than 99, we need to check if we had fire, and if so, remove it. Declaratively, it looks something like this. Notice how we're writing our code in terms of the possible states rather than transitions, and that the 3 different blocks we have here as part of our series of if-else map directly to the 3 states we had in the beginning. At the top, we have a check that if the count is 0, we'll just show a bell. If the count is less than 99, we'll show the bell with the badge and account. And lastly, if the count is now greater than 99, we'll show the bell on fire and set the count to 99 plus. Notice how it doesn't really matter what state we're coming from before. We don't really have to worry about that. Instead, we just express what the state should look like, and the framework takes care of everything for us. So now, if our designer comes to us with another state, all we need to do is just represent that here as another code block, and our work scales linearly as we build more and more complex UIs. With React Native, web or front-end engineers familiar with React can immediately write mobile features without having to learn traditional Android and iOS development, making mobile development much more accessible. I have a brief hello world here written with React. And now it's React Native and almost identical. Next, let's look at Instagram's React Native integration. Unlike an app like Facebook's Ads Manager that was built from scratch with React Native, Instagram clearly already had existing native Android and iOS apps. Bringing React Native into this type of environment introduced a few considerations. Let's walk through them. First, infrastructure. We have existing infrastructure to handle tasks like network requests, experimentation, and navigation, and does them really well for our use case. We want to leverage these existing components rather than write or use new ones. And while we do share pieces of infrastructure with Facebook, much of Facebook's custom React Native infrastructure wouldn't be Instagram compatible due to differences in our apps. We also have existing features and flows that need to integrate well with any new ones. You shouldn't see a feature and think, oh, this must be written with React Native. React Native is a native experience. The transition between features built natively or with JavaScript should be seamless. Next, our users have expectations for our app. We want to maintain app quality and consistency of experience independently of how we may be implementing a feature. And lastly, we already have a number of teams working on Instagram, writing features natively for Android and iOS. We want to maintain their developer experience, an example being symbolicated crash logs for engineers working with React Native. So now let's see how these come into play through examples. Let's start with infrastructure, using the example of a networking stack. While the open source React Native implementation uses the OK HTTP client on Android, we have an internal networking stack that we use at Instagram. We want to reuse our existing infrastructure while avoiding the additional app size and complexity that comes from having 2 different networking stacks in our app. So first, let's see how the out-of-the-box React Native setup works. On top of the OK HTTP client, we can add a Java networking native module. Mike had introduced native modules as one of the important properties of React, and they're made use of through the framework to expose functionality from native to JavaScript. Next, we have the bridge that handles communication between native and JavaScript. And on top of this, on the JavaScript side, we have RCT networking, requiring the native module. And this all gets bubbled up to the Fetch API, which you might use for product development. To reuse our existing infrastructure, we can add a new native module that calls directly into it, while implementing the same interface as the networking native module. Because of the layer of abstraction provided by the bridge between native and JavaScript, this works right out of the box without any changes. Put another way, RCT networking on the JavaScript side doesn't care who and how native is implementing the interface. All it cares is that someone's implementing this networking native module, and from there it can use it independent of what that implementation looks like. On top of this, we can also add a lightweight JavaScript wrapper around Fetch that handles path expansion and other common logic for our app. Now, product code can use this API to make networking requests through our native networking infrastructure from React Native. Let's go back to features. Remember, we want to maintain visual consistency between any features written natively or with React Native. So we can use the example of orts and dialogues. On Android, we have a class, IG Dialog Builder, that we use to construct stylized dialogues. And now, let's say we want to provide access to it to React Native. First, we'll create a new native module on top of our dialog builder. As before, we have the bridge that handles communication between native and JavaScript. And we can now add a JavaScript module, IG dialog, that will call into our custom dialog builder on Android. On iOS, we can continue to use the default implementations provided by React Native. So now, as a product engineer writing a feature for Instagram, you would use IG dialog directly. And this all ties back to how React Native offers portability. Engineers write the vast majority of the logic as if for one platform, but it can actually run on both Android and iOS and feel native. Moving on, let's talk about user expectations. One important example is performance. We want our React Native features to feel performant and maintain the quality bar associated with our apps. Let's see how we can use Logic Native to help us measure performance, letting us capture metrics like the overall time to interaction for a React Native feature, how long it takes to initialize the bridge, and time spent executing JavaScript code. We start with a performance logger. This isn't a native module, just a regular class. Next, we have the bridge. We can subscribe a listener to get notified when events of interest happen. This way, we'll find out when things like the bridge finished initializing or we started to execute JavaScript code. On the JavaScript side, we can have our product code render a flag to indicate when content has first appeared. This is really just a dummy view that we actually implement on native as a view manager. And then when it's attached, we can now mark the end of our performance event. At Instagram, our engineers are used to receiving detailed crash logs and stack traces that help them continue to improve their features. They have every right to expect the same of React Native development. We want to provide a consistent experience. With React Native, there's a native exception manager that registers with the bridge to handle JavaScript exceptions. That looks like this, similar to the other native modules and how we registered for performance events. As with the networking module, we can swap in our own implementation of the exception manager and pipe errors to our existing infrastructure. Now we can handle JavaScript exceptions just as we would native ones. Next, I'm going to show our initial experiments. These were screens ported by our team as we tested out React Native in production and built out our infrastructure. For initial tests, we looked to start simple and pick the push notification settings screen I showed earlier. This was formerly implemented as a web view, which meant it wouldn't be hard to beat its startup performance, and it also had a simple UI that didn't require much navigation. And we even got translations from the server. As part of this test, we audited metrics and compared them to those of the web view. Next, we looked to test a more complicated feature. And we chose to port the existing native edit profile view for an experiment where we could do a controlled experiment across native. This gave us a chance to build out infra like navigation, translations, and core UI components as needed. We also used this feature to evaluate performance and metrics against native as we iterated on and continued to improve our infrastructure. Now I'm going to show some examples of features implemented with React Native, highlighting what's interesting about them. Let's start with Post Promote. Instagram has a lightweight interface for promoting posts called Post Promote. This product was originally implemented as a web view because that technology allowed the team to iterate faster than they could with native code. As you see here, it's a fully React Native experience that you enter from on top of a feed unit. And what the team had seen before moving over to React Native was that with web views, your user experience doesn't feel native and startup can be pretty slow. The team ported this feature to React Native and measured improvements on both startup times and user engagement. React Native's portability also let us reuse payments code and logic from Ads Manager and Facebook without having to pull in native dependencies or work around differences in our native stacks. Next, Instagram also shares insights with businesses and top accounts. To improve their developer velocity and eliminate inconsistencies between the Android and iOS implementations, the team rewrote insights in React Native, giving them one single implementation to continue extending going forward. In the first image, you can see a React Native implemented drawer on top of our feed unit. The drawer shows insights on your post and can then be dragged to expand into a fully React Native post insight screen. Insights also shows accounts and stories insights. The stories insight screen displayed to the far right features a seamless mix of both React Native and native views. The screen itself is implemented in React Native and uses a view manager to embed and reuse native carousel story viewers, seen at the top. Next, checkpoints. Checkpoints are flows triggered from the server in response to suspicious actions, and historically they've been implemented using web views. The team worked to revamp many of these flows and decided to use React Native to improve user experience and startup times while leveraging code sharing. The first of these surfaces is an SMS-based challenge featured here. React Native lets a team that primarily works on the server do high-quality client-side development without needing to first develop mobile expertise on 2 platforms. So, how do we decide when to use React Native? Here are a few considerations. Let's go through them. First, existing code. Is this a new feature? React Native could be an option. Is this a small addition to a feature with significant native code? Then it makes sense to stick with native. What are your features' dependencies? What other code do you use? If you'd like to reuse code from Facebook, it could be easier for us to do so through React Native. What are your features' requirements? What are you optimizing for? React Native is great for shipping products quickly. Meanwhile, if you have a highly performance-sensitive feed-based feature, it makes sense to stick to native where we already have many performance optimizations. And lastly, what is your team's skill set? Who would be working on this feature? One of the advantages of React Native is that it lets web engineers write mobile code for Android and iOS, and mobile engineers can now write for both platforms. To conclude, I'll leave you with a quote from the React Native website and my take on it in the context of a hybrid app. React Native lets you build mobile apps with only JavaScript. For Instagram, we use React Native at the individual feature level, integrating into our existing Android and iOS apps. And as shown by my examples, native modules and view managers are powerful features that can live behind the bridges layer of abstraction and fit well into writing cross-platform portable feature code. That said, I like to think of it as this. React Native lets you build features with JavaScript, but still jump into native when it makes sense. Now, I'm going to turn it back over to Mike to talk about React VR and Oculus.
Awesome. Thanks again, Brian. Awesome stuff, and actually really insightful to see how Instagram is taking a much more sort of an incremental approach to using React Native. So now I'm going to move on to React VR at Oculus. To kick it off, I thought it might be really helpful to help understand where React VR has been used, and I suspect it might be in more areas than you'd expect. So React VR was actually first started in the true traditions of a Facebook hack, but it was then used after that as an integration to an established application. That was Oculus 360 Photos. At the time, we were extending the photo viewer application to be able to browse Facebook 360 content. And React VR allowed me to integrate the photo description page, and that was sourced from Facebook Infra. And I was able to share established Facebook JavaScript code with relative ease, so it sped my developer velocity up. Now, to put this in Brian's terms, React VR in Oculus 360 Photos was a feature of the application. It worked alongside the other workings, and it was the best technology to solve that immediate problem. Now, I can see a number of blue bags here, because this slide will be very relevant to you. So not long after completing work on 360 Photos, a new opportunity arose. The mobile team in Oculus started working on a new application, and this one was designed to writing VR applications and making them simpler to create. But what they needed was a simple framework so that the developers could actually unleash the power it provided. And this is where React VR came in. We took the 360 Photos React VR, we wrote a new render and supported a number of teams to allow them to release their products. And what you see is Oculus Home. And this is actually one of the initial interfaces you'll see when you first start up your Go. And you'll also see that in a number of other apps, Gallery, and they're available for your new device. But these were stood up in only a few months, and the main differences over 360 Photos were that there were 80 to 90% of the application was written in JavaScript, and the team was made up by both seasoned VR veterans used to writing native and C++ codes, but also folks coming from web backgrounds. So React VR enabled a number of these applications, as I mentioned, and they were put together very, very quickly. And these are the full React VR-based applications, completely written in JavaScript and making use of those awesome native modules. Next, moving on, we started expanding our supported platforms, and what you see here is actually Dash, and is the main UI you'll see when you put on your Rift headset. Dash brings a control bar in which you can access your standard desktop applications such as Chrome or Firefox. But it also allows you to bring in React VR panels, and in fact the main bar that you see at the bottom is actually all written in React VR. And it enabled developers working on mobile to transfer their skill set over to PC with relative ease. And this is running on a different engine and a different development environment. Now, the final example we see here is really super interesting, but it also introduces a new platform, and that's Unity. So up until now, I focused on 2D UIs placed in 3D space. However, React VR and the components are much more than that. Rooms, which is what you see here, is a social application for VR. It takes React VR in a new direction, and that's board games. In reality, there's no rule that a UI has to look like a set of rectangles. And in fact, here, what we're doing is actually making use of models and 3D, and we're using the same sort of interaction paradigms. But on top of that, there is actually also no rule that the state that is used to represent that UI can't be shared across different devices. And the team, by writing more native modules and integrating with a Redux store, they were able to create tabletop experiences that could be played on different devices separated by thousands of miles. So by building the tabletop experiences on React VR, the team could also separate out who could author these games. And this allowed them to scale by bringing in off-site engineers who didn't know have to know about the inner workings of their Unity application. So how did we arrive at the decision of using React for all this work? And it's a very fair question, and one I'll look to answer over the next few slides. But really the spoiler is our reasons are very similar to Instagram's and those you'll see have heard about the panel bit just before us. There are three important points. First, platforms, as we'll dive into in a minute. Oculus has many. Secondly, we want the users, for users, we want the best for our users, and developing new technologies, that often means iterating quickly and shipping often. And of course, teams need to be well supported. Now let's start with platforms. For us, there are two axes of the platforms for VR. First, we have devices, and then secondly, as we'll talk about in a minute, is the engines. And because of that, we have a lot of permutations, and React VR becomes a solution to all of these. So let's first have a look at the spectrum of devices that we run within Oculus. So on the left, there are the devices which track head rotation. These are commonly known as 3DOF devices. And the far left that you have is the Gear VR, and then the Go, which hopefully you will all receive by the end of today. And then on the right are the devices that track your position in the world. And first of all, this one is a prototype device called Santa Cruz, and then the Rift. We develop for all of these, and each has different requirements for both for input, display, and the interactions. The goal of React VR is to hide these differences wherever it makes sense to do so. So the other axis is engines. Now, most applications on the store use either maybe Unity or Unreal, and Oculus Rooms and Spaces are two examples of these. But we actually want to integrate with those as well. But many of our full applications also make use of native code. So in total, we're up to 12 platforms with all various different capabilities, but we found it common to want to share between these, and a good example is that tabletop game. As you'll see soon, by writing a platform-neutral runtime and leveraging that declarative power, we are able to create a runtime that not only display the same content, but also demonstrate the learn once and write anywhere phrase of React Native. So users are at the forefront of our mind, and there are a number of areas in which having React VR has been super beneficial. Ultimately, it revolves around being able to change, iterate, and move fast. So no one wants to wait for an application to start, and by owning the whole stack, React VR has given us the means to be responsible for it. For example, previous versions of Home used an engine, and the startup time was well over in 10 seconds in areas we were just not able to control. React VR allowed us to focus on any area and optimize what matters by being able to measure the whole stack. And this allowed our application engineers to concentrate on the high-level optimizations. And for Home, this meant we could achieve a fantastic speed up to first interaction. In fact, it was 3 times. Secondly, VR is power intensive, but there are specific areas of the technology which consume more power than others, and one of those is rendering. By knowing this, understanding the stack and making the React state updates work for us, we got to the point where we only had to render the scene where necessary. And this was achieved without any changes for the application developers and reduced power consumption by over 30%. Now, a long-running problem has been text in VR, and as the graphics suggest, it can appear blurry. However, John Carmack had an idea, and he introduced a special rendering method that meant text appeared clear for no extra rendering requirement. This new feature was able to be tested and shipped at Facebook speed because we could make the necessary changes. Owning the display meant we could own the problem to the benefit of our users. All these fantastic technical benefits really were without making any changes to the application code. Now, Teams is our third pillar. Like Instagram, Oculus values development velocity, and we've achieved this through sharing solutions and building on React dev tools. So let's go over those highlights. First is bringing order out of chaos. On mobile UI, it's relatively easy to think about the 2D layers that make make the application. But for VR, it can be overwhelming. You can look around, you have a full 360 view, and panels can be anywhere. But we've learned to think and help our developers by taking these into distinct layers, and these are environment, panels, and scenes. So the environment can be thought of as the background or even the wallpaper of VR. This type of content is simple to generate given the proliferation of 360 cameras. To support this, we created a new component that allowed to display 360 media. It acts in very similar to an image tag that you would see in React Native. The next layer is the panel layer. You may have multiple of these, and all of these are addressed with 2D pixels to make everything as simple as possible for all of our developers. These display 2D content and are laid out using Yoga, another popular open source library. The final layer is the scenes, and these are generally 3D models, and particularly interesting as demonstrated by the tabletop games. And as headsets get more advanced, we really believe that these will be heavily adopted by React VR users and drive new interaction models. So now the important thing is that each of these can be represented with a React VR component, and each can connect and interact using the same paradigms. Now, the most commonly used native view types are view, text, and image. However, this is not something you want to subject to all your application developers to. By promoting sharing and high-level components, it's been possible to define style across a range of applications, as well as keeping the input models tight and consistent. And this is where we use React's powerful composition model to implement a set of common UI elements. This started as simple buttons, but has developed into more complex UI elements such as dialog boxes. Within Oculus, this is known as OCUI and has provided a means for teams to make large and consistent changes across a range of applications on multiple platforms. This practice has reduced bugs and allowed engineers to move between platforms with relative ease. Now, so best practices and features are part of the story, and React VR, to be honest, is made by developers for developers. And considerable effort has been placed on making sure the developer experience is fast and useful. Developing on engines and native is often associated with long build times and slow deployment to device. With React VR, these are gone for all of our developers. They have access to that Chrome debugger, which allows JavaScript code to be stepped through. But iteration has also been a consistent focus, and we make use of hot reloading. This means we can make changes to code and carry on executing while the headset is still on, and this is super powerful for all of our designers, where we can actually make those small incremental changes, and they can see the results reflected immediately. And so I'm now going to do a bit more of a deep dive into the technology of React VR, and this is where we depart quite a bit. First of all, we built React VR on the public GitHub version of React Native. And second, we don't use any of the same runtime as React Native Android or iOS. And in fact, React VR happened to, to make React VR happen, we needed to implement our own advanced UI library. So this is the tech stack we have. First, what we've outlined here is what I termed the runtime. This is the code that the React VR team maintains and is reusable across all of our platforms. Now, working from the top to the bottom and the highlighted areas, at the top is a small amount of JavaScript, and this corresponds to the JS components and modules that make sense for VR. For example, custom additions to text or view. Next, we have a C++ implementation of the core system modules, for example, UI Manager, modules to deal with networking, WebSockets, etc. And this is the place where we tightly integrate with the fantastic developer tools that the React Native provides. The Chrome Debugger, Inspector, and Hot Reloading, all tools that both we and the teams we support find indispensable. At the base level, we have a custom renderer for all our views. We can't make use of any of the view systems that are available on Android or iOS, and therefore we've had to implement our own scroll views, image views. But what we've made is pretty cool because we can optimize it for our use cases and also how we interact with them. Finally, this outputs rendering commands to a varied graphics libraries as one of the keys to making React VR cross-platform. On mobile, we use OpenGLES. On PC, we use Vulkan or DirectX. And we've been very thoughtful to place this very platform-specific code away from the majority of the shared code the application developers use. So now we move on to the parts of the stack where the applications are authored. And as you can see, they're very insulated from the nitty-gritty of the VR APIs. At the top of is the application code, or the for full applications, all the logic is here. But as you notice from the diagram, authors are able to access those custom views and native modules because those can become super important. In fact, many of it wouldn't have been possible to implement many of the features of Home without access to those. For us, however, the update loop is very similar to the standard React Native, and in fact, this actually presents a massive advantage. It allows the JavaScript to run asynchronously from the very fast updates that we need to make for VR, which could be 60 hertz on mobile, in fact, and 90 hertz on PC. we make use of the same idea of message passing between the two threads so we can minimize the synchronization between them. So while we've made some amazing progress on our journey, and really the story of React VR is not yet complete. There's more to do and more to address, particularly as it's a rapidly developing technology sector. First of all, the areas we're going to be looking at much more aggressively is performance. There's no doubt that TTI times have declined as more and more features have been added to our mobile applications, and therefore we need to be vigilant of addressing these. Now, part of these is using similar ideas to what Instagram are using and introducing careful measurement and instrumentation to determine when a slip happens. But performance is not just about first interaction. And this is where building on more of the native makes sense. We've already fully adopted native animated as the best ways to express animations in React VR. But we're now looking at ways of declaratively expressing events so that time-critical interactions can be expressed in JavaScript and run fully on the native code. The second thing is we're heavily looking at is new capabilities. And again, as we know, this is a rapidly developing sector. And so we're going to be really doubling down on heavily integrating the 3D elements that you see in rooms across all of our supported platforms. This is undoubtedly going to involve adding new input models and seeing how those affect the rest of the stack. But the important thing is that this is the next stage in aligning. But this needs to be aligned across all of our platforms to really fully fully leverage the learn once, write everywhere. It is, of course, still early days, and yet we've already shipped a lot of product on React VR. However, we can never sit and rest because the new technologies evolve at a rapid pace, and we, React VR team, will need to always aim to hide that complexity and keep allowing our developers to iterate at speed. I'm now going to hand it back. So now you've got a summary of React VR. I'm now going to hand it back to Brian to summarize the complete.
Thanks, Mike. Now that we've seen how we're using React Native at Instagram and React VR at Oculus, let's revisit Mike's initial introduction of React. Mike mentioned 4 important properties: declarative layout, component-based, native modules, and learn once, write anywhere. So what were the benefits? Declarative layout unlocks developer velocity benefits. By expressing our layout in terms of states, we can scale our work linearly as we add more states and build more complex UIs. And this idea of a layout as a function of state lends itself really nicely to workflow improvements like live and hot reloading, something we take advantage of at both Instagram and Oculus for faster development. Next, component-based gives us portability. We can solve a problem once and create reusable, composable building blocks. And we can stack these on top of each other, hiding away complexity at lower levels of the stack. The same components can run on both Android and iOS and feel native. We could presumably even reuse components between Instagram and Oculus. And then, when we do want to drop down to native, we can use native modules to reuse existing infrastructure and tighten our integration. And lastly, learn once, write anywhere gives us company-wide benefits. As I mentioned before, normally it would be quite strange to think that Mike and I are up here giving a talk together. But with React, different parts of the company that would normally have different tech stacks can now follow the same patterns and share resources and thought processes. Folks working with React at Facebook or externally can come in and contribute on mobile and VR, while someone developing with React Native at Instagram could conceivably go and be very productive at Oculus. With that, I'd like to thank you for joining us today and hope you enjoy the rest of the conference.